Okay, I just put out the answers to the review in Google Classroom, but I promised first period today that I would do, first period today that I would make a video of me doing the review since first period won't see me again until this test, which is next Monday. Second period will get to see me tomorrow, Tuesday, and Thursday, so they may not need as much help, but I'm going to make this available to everybody anyway. So this copy is really bad. I apologize for that. So I will go through a bunch of these in class for you guys. Already have, but here is a video of me doing them anyway. So number 1 says the limit as x approaches -4. So that is the key, is that limit part right there. So you should have your own copy and you can see it. I don't know if I can zoom in enough. That's as far as I can get it zoomed in. So -4 is right here. Oh no, it's not. That's a -6. See, I have my glasses on. I still can't see very good. So that's -3, -6. So -4 would be like right here. So we're wanting to know, what is the y value at? Well, that's really hard to tell, right? It's, I don't know, somewhere in this area, maybe. So on this one, it would make sense to go ahead and plug that -4 into the function. So here we go, -4 squared minus 3. We can actually use direct substitution. -4 squared would be 16, positive 16, minus 3 is 13. So it's actually higher than what I expected. It's right here. So the answer to number 1 is 13. So the trick on that one is to plug it in because it's too hard to tell on the graph. Okay, number 2. Trying to get it to lock in. I can't get it to lock in. Okay, this one says the limit as x approaches 2. So here's 2 right here. There's 2. You always have to look at the increments here. So as the graph comes from the left and the right, what is the y value going towards? Now this one we couldn't plug 2 in because it would make the denominator 0. So we can actually look at the graph to answer this question. That y value is a 12. So the answer to number 2 is 12. That is the y value. Number 3. So number 3 is the limit as x approaches -2. Again, we can't plug in that -2. I don't know what's on my pin here. Because it would make the denominator 0. So we want to look on the graph. On the graph, it's right here. Here's approaching from the left. This isn't staying focused. This is approaching from the left, and this is approaching from the right. Obviously, they go to 2 different values. So if they come to 2 different values, the limit does not exist. That is not O-N-E, that is D-N-E, does not exist. Number 4. So number 4 is the limit as x approaches 1. Again, we could not plug that 1 in. It'll make the denominator 0. 1 is right here. If you look at it from the left, it's going down forever, and from the right, it's going up forever. That's why there's an asymptote there. So since the left and the right do not agree, it does not exist. All right, number 5. Number 5 says the limit as x approaches 0. Again, we can't plug in 0 because it's in the denominator. 0 is right smack in the middle, and this might look weird to you, but it's bouncing up and down. It's oscillating. So that's what that graph looks like. Since it's bouncing or oscillating, the limit also does not exist because it keeps bouncing back and forth and never stops. Number 6. Number 6 says the limit as x approaches a -1. -1 is right there. So as it comes from the left and as it comes from the right, it is going to the same y value. That y value is -1. It's almost too easy, right? Almost too easy. All right, this one, number 7, the limit as x approaches pi over 2. Pi over 2 is this asymptote right here. And on the left, the graph is going up forever, and on the right, it's going down forever. So again, the limits do not agree on the left and the right, so it does not exist. Number 8, this says the limit as x approaches pi over 2. Pi over 2 is that asymptote right there. If you look on either side of that asymptote, on the left it's going up forever, and on the right it's going down forever. Those do not agree, so the limit does not exist. That is how you answer graphically.